Welcome, everyone. Thank you for joining us in today's AI Explained on machine learning for high-risk applications. My name is Krishnaram Kentapedi. I'm the Chief AI Officer and Chief Scientist at Fiddler. I'll be your host today. Please feel free to put in your questions in the Q&A at any time during the fireside chat. We will kind of alternate between some questions that I have for our special guest and also the questions from the attendees. Also, by the way, the session today will be recorded and shared with all the attendees after the session. We have a very special guest on today's fireside chat, and it's Parul Pandey, a principal data scientist at H2O.ai, and also the co-author of the book Machine Learning for High-Risk Applications. Welcome, Parul.
Thank you, Krishnaram. I'm so glad to be here and also very excited to be here on the podcast and to share my experience with others.
Let's start with the book itself. I read a few chapters in the book and I found it very, very insightful. For the benefit of our attendees, could you share perhaps the key takeaways from the book?
Yeah, sure. So, the book's name is also High Risk Machine Learning for High Risk Applications, which is also the title of today's fireside chat. And it literally is. It just tells you and gives you ways and guidelines for doing machine learning for high-risk applications. So the way we've divided this book is in two halves. So the first half tells you about the technical aspects of what you should do when you are creating a product, AI products or machine learning products, especially which are in high-risk domains, the healthcare, financial domains, banking sectors. And the second half of the book has implementations in Python. So for the ones who want to actually go and code and see the code and want to replicate the stuff, we also have something for them. The main crux of the book actually is, so we three of us who wrote the book, it was me, Patrick Paul, and James Curtis. What we want to actually tell people is machine learning or AI products, like any other technologies, can fail. And it's absolutely possible they can fail. Most of the time when we build AI products, we're always so positive that this is going to change education, this is going to change healthcare, this is going to change everything. We don't see on the negative side of it. And it's always humans on the other side of it who always get, maybe they're denied a loan, they're denied some healthcare opportunities. So what we are saying is ML can fail, yes. It could be by intentional abuse or maybe unintentional activities. So we've tried to sort of give ways to ensure that how you can manage it. Of course, this is not a golden rule or something. It's from our own experiences that we've tried to put in. And we sort of give certain guidelines that people can follow in order to ensure that whatever they create doesn't harm anyone. So that's in short.
Yeah, yes, I think this is very, very relevant in today's context, right? Like, I think maybe if I could add to that or rephrase that, you're emphasizing that as technologists, we should not just design thinking that everything will go as intended, right? We should also perhaps loop in all the relevant stakeholders, understand what might be the potential negative impacts or unintended ways in which the technology might get used. This is particularly pertinent for the machine learning or AI applications. Right? So in the first chapter in the book, you discuss the risk management framework for AI proposed by NIST. So by the way, for anyone who's not familiar with NIST is the National Institute of, I believe, Science and Technology.
Standards and Technology.
National Institute of Standards and Technology in the US. And NIST comes up with lots of standardization frameworks. And one of the recent such frameworks is the AI risk management framework. Could you perhaps give us an overview of this framework and how it can be applied by data scientists and machine learning practitioners?
Yes, so we've mentioned NIST a lot of time in the book, so I think this is a good platform to talk about it. So, like you correctly said, NIST is an acronym for National Institute of Standards and Technologies, and it's a body that falls under the U.S. Department of Commerce. So, what these people did was they took in the collaborated with the private players and the public sectors and experts in those sectors, and they together came out with a document or a framework to better manage the risk to individuals, to organizations, etc., which comes associated with AI and machine learning. So before this, I think it's interesting that machine learning, so to say, doesn't have those uh, strong guidelines or framework. There's a lot of talk right now going about regulations, but everything is in a very nascent stage as of now. Uh, we do have some small things, but I think NIST AI RMF or risk management framework was the first such framework which actually put forth broad ideas as to how to make your products more trustworthy. But there's an important thing that I like to say here, and also we put in the book, that the risk management framework is a voluntary tool. It's not a regulation, and NIST is not a regulator. So that's not a regulator. It's a voluntary tool which you as a company or as an individual can adopt. But it's very nicely written, and they basically have the four broad areas under which they sort of classify the risk. So they have the four categories are govern. So, how do you create a culture or how do you cultivate a culture of risk management in your organization? How do you map the risk? How you measure the risk? And then how you mitigate those risks? So now what we've done is to follow on our own advice as well. In the first half of the book, in every chapter, you'll find a call out table where essentially we've mapped every section of that chapter to the risk AI RMS section. So this is helpful in two ways. People who've read the NIST AI RMS can see its practical implementation via our book. And the people who haven't read the NIST framework, they can read our book and then they'll get an idea of what are the important aspects of it. So we've really worked very hard in actually aligning every chapter and every subheading with the NIST framework. So essentially, like I said, it has those four broad pillars of govern, map, measure, and manage. And everything they try to put under those subheadings.
Yes. In fact, that's one aspect I really liked about the book, which is this mapping, right? So it comes across as it's not just maybe abstract guidelines, but it's very, very practical and hands-on guidelines for data scientists and machine learning engineers and other practitioners. And, say along those lines, like what could you shed some light on? What are some of the organizational best practices for machine learning risk management?
So I think whenever we talk about any organization and sort of inculcating practice so that we create good, trustworthy products, I think first and most important is it has to be a holistic approach. That is, it has to flow from top to bottom. Responsible AI is not something like, and then after we create a product, we just sort of just add this few post hoc techniques and say, look, we've tried to use chat, we've tried to use Langman, this we are explaining. It has to be a whole process. And one of the greatest examples that we can borrow from is the banking industry. So banking industry is a highly regulated industry, and they've been regulated and they work pretty well. And they have a concept of something which is called Model Risk Management Framework, which is MRM. And it basically, MRM itself derives from the Federal Reserve SR 11, 11-7, and this came into being after the 2008 financial crisis. So they made sure that something that happened in 2008 doesn't replicate. And so there are a lot of good things that we can borrow from there. And I think the first one would be, so we've written about it a lot, but I'll just cherry pick few of them. So one of them I think is forecasting risk failure mode. Now, this is a little funny because, you'll say that you cannot forecast failures beforehand when you're creating a product. How can you do that? But this is where I think if we are able to do that, we're going to save our company a lot of money and peace. So one way to do that is essentially have an incident database. There is already an AI incident database for the ones who want to look up. If you write AI incident database, it's a database of all things wrong that have happened with AI, and it is as latest as maybe I think few months back. So they've shown examples and some of the, so we always talk about some of the known examples. We talk about ProPublica, we talk about the Tay chatbot, but some recent ones is the Robodex fiasco that happened in Australia. There's one recent which happened in Netherlands. So these are learning. So if we are creating a product which is very similar to the ones, this is going to be a lot of red flags. And we will know that we don't have to repeat what has happened in the past. Essentially, you learn from the past so that you don't repeat it in the future. The other thing I think of model risk management would be risk theory. You tier your products into like high risk, low risk, medium risk, so that you don't have to put all your workforce, of course, we understand that not all organizations have such a lot of workforce there to take care of every single risk. So you can tier your product into 3 risks. Create robust documentation of the models, something on the terms of model cards or data cards that we see today. I think it's being followed. I see a lot of large language models that are coming out now, the open source one. It's very nice to see that all of them are coming with model cards. But we need more robust ones actually also telling when and when not to use them. Have good model monitoring processes in place. Check for drift whenever drift occurs, check for model decaying, so on, I think. And another important thing I think just to add, and I would also like to have your opinions on that, Krishna. I think when a team is working on any AI tool, what most of the time it happens is they are the ones who create it and they are the ones who test it. On the contrary, if we could have another team which is working on a very separate project, be the ones that test it, I think not only will be able to make it more robust, but they'll also be, capable of looking at maybe the darker side of what the team who's creating is not able to see. So these are just a few of the ones.
Yeah, yes, I think that that's a really interesting observation. In fact, I have seen that the banking industry does something along these lines. So there is a team that develops machine learning models, or even broadly any analytical models. There are other teams which actually measure the risk or other effects of these models. So I think that creates a nice structure where there are, and these two teams may have slightly different incentives, and there is a kind of positive tension and a tension in a good way between these teams. So it's not as though people who are developing the models may be malicious. It's unintentionally they may not check for, say, biases or other blind spots, and so having a different team that serves as an auditing or a layer, risk management kind of layer before the models are deployed, I think helps a lot. This is a practice perhaps that other industries can also potentially adopt. Right? Like at tech companies, I have seen the structure where there is often a team which develops the machine learning models, or the data science or the AI team. But often in sensitive domains, the team needs to get approval from the security, legal, and like PR teams. So these are other teams. The security, legal, PR often act as kind of checks on what gets deployed. But the challenge is that often they may not have enough bandwidth to review each and every feature or machine learning product updates that happen. So the focus gets confined to some of those highly sensitive domains. At least this was the case when I used to be part of LinkedIn several years back. But I think, as you point out, having separate teams focused on risk assessment and focused on auditing and so forth, it's always a great idea. And the key thing in all this is the right incentive mechanisms at different levels in the company. It doesn't really help if, say, the leadership is passionate about responsible AI or is aligned on ensuring that the machine learning and AI models are trustworthy, but the data scientists or the other teams in the organization are not sufficiently incentivized. Often I say that the data scientists should get as much incentive finding any issues with the models
Yes,
as they get
yes.
when, say, they result in business metric improvements. I think that's more like in cultural and organizational aspect that as leaders, the leaders at an organization should kind of inculcate across the organization.
Totally. I think, and just one example that came to my mind was, if you remember the Twitter algorithm, of course, before the Twitter 2.0 that we are seeing now. So before that, they had this image cropping algorithm, which is essentially that if you put up any pictures on Twitter, so what you see on your timeline is decided by that algorithm in a way so that you can get more eyeballs. And one day, suddenly, one of the person had put up a tweet there that it was favoring fairer people, and it more than the darker ones. It was favoring females and a lot of other problems that they had. And at that time, then Twitter actually realized that there is some issue with their algorithm. And so much so that they had to scrap that algorithm, and then they organized a bug bounty. Basically, they asked people to come and test their systems. So I think bug bounties are also good if you have an open source system, of course. You can't do that for closed ones. But they organized bug bounty. People came and they actually showed flaws in their algorithm, what it was. It was a very nice case study, actually. I think OpenAI is also doing a bug bounty. And then yesterday, Llama 2 was released, the LLM, and I was going through the white paper, which is like huge, but it was very nice to see a complete section dedicated to responsible AI. They've created a framework, and they are also going to incentivize people who are going to find bugs in their software. So I think these are good ways in which people are doing, and this could serve as potential examples to other players in the company in the same field who are working, that it's not always it's about the business. If you are going to make sure that your system is foolproof, it's going to give you better, I say, returns over a long period of time. Then you get sued by some person after a few years, maybe.
Yes, exactly. I think this idea of bug bounties is a really interesting aspect. I believe it originally came out of the security community, right?
Yes,
And
yes,
then
yes.
getting more and more adoption in other communities like the data science or machine learning community. And in fact, taking a step further, often when it comes to machine learning or especially like more recent large language models or generative AI models, there is often an emphasis on red teaming, again, like inspired by the red teaming in the security community, where just like bug bounties, the focus is also on discovering issues internally before perhaps making the product available externally. I think bug bounties, red teaming, and reviews by perhaps different teams with the appropriate incentive structure. I think all these are perhaps part of the solution for addressing model risk management. We will get shortly to the elephant in the room, right? Like the large language models, generative models. But before that, I would encourage all the attendees to post their questions in the Q&A. And it's nice to see the comment from one of the attendees that they read your book as part of the summer course that your co-author Patrick Hall taught. It's really nice to hear that. So in the book, one of the incidents you discuss is what happened with Zillow's iBuying program. Could you perhaps share some lessons that we can learn from the rise and fall of this project?
Yes, so we've tried to also give case studies where, because case studies always help to understand things better. but in no way like they're trying to point out that Zillow did this wrong, or this could have happened with any company. And I personally know a lot of brilliant engineers who work at Zillow. But this is a great way to understand what can go wrong if you miss out the red flags. So Zillow, as everybody knows, is a real estate tech company, and it sort of changed the whole real estate market uh, in its prime. So in 2018, if I'm correct, I think it entered the business of what is called iBuying, which was initially called Zillow Offers, and then it was called iBuying, which was, it started buying houses, under market value houses, and then it started to refurbish them, and then it sold it for a profit. So they started doing it in 2018. And initially what they did was, they brought in a bunch of people whom we could say domain experts, or maybe the local real estate people and other domain experts. And they had this ML algorithm, which they call Zestimate, which is a Z in front of estimate. And they use this to sort of predict the price of the houses. So if we see that local real estate agents have a lot of know-how about, what is going to be the price of this house, or what is tomorrow going to be developed in front of the house, will its property valuation go down, go up? So these people have a lot of knowledge about that. So so they started predicting the house prices, and but what happened was the house pricing market during that time was pretty much inflated. And because the domain experts take time, because we are humans, we sort of taken a lot of variables into account. Zillow sort of they wanted to get the offers fast. And so what they did was, to scale up, they sort of got rid of the first red flag, they got rid of the humans in the loop. So they solely started relying on their ML algorithm to predict prices. Now, they were in such a rush, or they wanted to scale so fast, that they actually acquired properties at the rate of about 10,000 homes per quarter, which is huge. Now, you acquire such a lot of houses, then you also have to flip them, you have to sell them. But houses, unlike any other product, even let's say used car, it takes time. You have to refurbish, you have to renovate a house, and only then can you sell it. The problem is the local contractors could keep up. It used to take time for the house to, and then COVID struck, pandemic struck. So again, they did not have those local renovators. The house prices market also started to slow down. And then what happened was a total, you could say, what a company like Zillow would have never expected was a lot of houses, inventory just sort of going up. They were not able to sell the houses. And the situation went so bad that literally they had to post their houses at a loss. I mean, even lower than what they bought it for. Not only that, they had to write off $500 million. And the worst part, and this is where I say that, at the end of wrong decisions is always human. They had to let go 2,000 of their workforce, which is like 1/4 part of that. So ultimately, yes, the company incurred losses, but I think the ultimate is a lot of people lost their jobs. And they might be from many other departments also. They could be from human resource, they could be from marketing, they could be from anyone. Now, this case study, what does it show? I think the first red flags for me is you should always validate with human experts. Human experts might not be always as fast as the algorithms, but their experience is very, very important, especially for high risk situations, especially this also I would consider high risk. Secondly, again, the word that I said, initially forecast failure mode. They should have thought like, what will happen if maybe the price bubble burst, the housing price burst, and what would happen? So they sort of should have envisaged it beforehand, before buying so many houses firstly. And I think model monitoring here should have, if they had a proper model monitoring framework, this should have actually raised the red flags. Like the model's accuracy should have gone down, because the price that their model or their algorithm was predicting was not the price that is now in the market. So there should have been a red flag that your model is decaying. There is a drift. And that is something which for me is very difficult to sort of digest that how they could do that. So essentially, I think, and it's also said that the governance is also gone because Zillow is actually the management there is always famous for risk taking, but this one went too far, I think. So for me, these are the 2 or 3 takeaways.
Yes, I think like these are all really insightful lessons, right? Again, from the spirit of what can we learn from this incident, as opposed to we're not necessarily pointing fingers at this company or any one company. I think, as you mentioned, just like in this case of real estate, in any domain, the models might degrade over time. Often, the conditions under which the models are trained may not necessarily hold during deployment. So it's very important to make sure that we not only like test the models before deployment, but continuously like keep auditing and monitoring them post deployment. Yeah, the other highlight I remember when reading this section in the book is you emphasize that unlike perhaps other incidents, AI related incidents can occur at scale, right? And so that's also a huge risk. This is an analogous discussion I recall reading is in the book by Kathy O'Neill, The Weapons of Math Destruction, where she emphasizes that when the data driven models have some biases, they have the potential to cause bias at a huge scale, unlike, say, let's say a human judge or a human expert who might have their own biases. So likewise, even with AI incidents, I think this fact that they can occur at this huge scale, and then that might result in huge impact in terms of business impact or impacting the people and so forth. I think that's something to always keep in mind.
Yes, totally. I think it's the dangerous aspect of this, like you said, is the scale, and the scale can be huge, and so the ramifications of it is also huge.
So I see a question from Apur. Would love to hear your opinion on risk management in banks. Often the risk management is driven by regulation, yet the banks seem to fail quite often. Where do you see the state of regulation in AI?
So I think this is what I also started with. We don't have any regulation in AI as of now. There's been a lot of voices around, and the EU AI Act, and but we don't have, and I think it's not very clear. So you have different groups now. There's one group which talked about existential risk. There's another group which is actually talking about that we're not worried about the existential risk. We are worried about the existing risks, which I mean like the biases and those kind of risks. And so to say, even I don't have any answer, like, because I don't know. And the weird thing is that a lot of people who actually are experts in that are not involved in those talks of regulation. If you've also seen, there are people who are meeting the presidents and everyone, but I've not seen anybody apart from the big companies there. So for me, I think a good way is NIST. For me, I think it's a good first way, and its regulations are based on something what risk is also proposed. It's something that I find easy to implement, easy to follow, because again, regulation should also be something that should be easy to follow and should be practical. So we have to, I think, in today's world and look at the pace at which things are going on in AI. I mean, it's like I was saying, when we started writing the book, there was no talk of LLM. LLMs for us were like BERT and things like that. And by the time we ended the book, it was crazy. Initially, we would talk about millions of parameters, but now billions of parameters has become the new normal. So we have to accept the fact that we are not going to go back from here. And we have to accept this and now create regulations in a way, keeping humans at the center stage and seeing profit away from what we are trying to achieve. And we are going to have voices from every sector here. It has to be a diversified panel who's going to make the final call. And this is what happened in NIST. So why I'm quoting a lot about from NIST is because these people were working for about 1 year or something. They opened up the draft to people. The people then also gave their recommendations, suggestions. Everybody was welcome, and then they finally created the whole AIRMF. So to be honest, even I don't know where this is going to go. We've had the EU AI Act there. Let's see. And then the weird part is every country also has to adopt. So every country will then adopt and then go from there. Honestly, it's a long road.
Yes. I think as you mentioned, with the rapid pace of developments in AI, makes some of the regulations a little bit harder compared to, say, a sector like banking. Even in a sector like banking, I do think that the regulations have helped a lot. The regulations, whether they are from an end user point of view, like the fair credit lending related regulations, or regulations from a risk management point of view, which are more like SR 11.7. I think these regulations have definitely helped. Even though we see a few bank failures, especially recent failures like the Silicon Valley Bank, the regulations still seem to have played a big role. In fact, one of the reasons perhaps this failure happened is because they were not covered by the regulation. If the regulation was perhaps more comprehensive, then these kinds of issues may have been detected early on. So likewise, I think in the case of AI, the challenge is to craft regulations at the right level. Like the regulations should not be too granular or too specific to kind of stifle innovation. At the same time, the regulations have to be at the level where it addresses different types of risks, right? I think the aspects like the NIST AI risk management framework, or the White House science and technology AI guidelines, I think all those are kind of right steps in that direction. Hopefully, like in sometime over this year or next year, we will see a set of such regulations. And of course, the regulators, those who are designing the regulations, have to collaborate with the people who are working in this field, so that the regulations can be done at the right level. So I see another question, which is for high risk machine learning applications, are model development standards, are there model development standards on how to build a predictive model? For high risk machine learning applications, do you think it's necessary to have model development standards on how to build a predictive model? For many people in the tech field, the main joy of doing data science is the experimentation aspect of the work. But in regulated industries, it may not be advisable. How do we align following the instructions from regulations and at the same time maintaining creativity and innovation?
So that's a great question. So, I think experimentation is always allowed, but what the regulators in the end want, and it's like if you also put yourself in the shoes of the people, let's say you applied for a loan and you're denied that, you would want to know why I was denied this loan. So anybody would want to know that. Now, the problem with some of the predictive models is that they are black box. And there's no way you can sort of tell, even for experts, even for the people who might have just written that algorithm, that how the model is making its predictions. So in that case, we have to go for models which are explainable. Now, initially I used to read a lot of forums and in a lot of, you could say, articles, that it was said that, there's a trade-off between accuracy and explainability, which means that if you want a highly accurate model, then you will not get an explainable model and vice versa. But we've also addressed this thing in our book. that sometimes, and there's a great paper by Cynthia Rubin who says that stop explaining high stakes decision with black box models. It essentially says that no, there is no trade-off. Today, we have models which are both explainable and as accurate, if not maybe more than your best model. So look at GANs, which is generalized additive models. So these models, they also preserve the interactions between the features. They also give you high score, high accuracy, but you can explain the decisions made by these models. There are others. So there's something by Microsoft, which is called explainable boosting machines. Again, those are also at par with your, let's say, XGBoost or Light GBM, but they're explainable. So if I give you a choice of, let's say, do you want an explainable, accurate model, or you want a black box accurate model? Which one would you choose? Uh, of course, I think the answer would be to choose an explainable model, because then that makes it easy for you to also sort of give explanations and reasons, which are also required by regulators. So that is something you should keep in mind. Of course, like if you're going to say about image and text, uh, we can't use those models, so that will have to go for deep neural nets. Then we also have to take help from some of the explainable techniques to apply for that. But if you are working for a domain where you have the choice between an explainable model and a black box model, I would advise to go for an explainable one.
Yeah, yes, I think these are really fantastic pointers. I would encourage all of you to take a look at the paper by Rudin in the Nature Machine Intelligence Perspectives, and also the other work from Microsoft Research. It's not as though there is always a trade-off. Often in the process of building interpretable models, or in the process of fixing biases of the models, we might end up improving the performance of the model as a whole. It may not necessarily be a trade-off between accuracy and fairness, or accuracy and interpretability, and so forth. So this might be a good time to kind of shift a little bit to the large language models and generative AI models. So as we discussed, they have been evolving at such a rapid pace. So as you mentioned in the book, the risk management for these systems is not as well understood as it is for, say, supervised models. What may be some of the guardrails we can consider in the meantime?
So yes, I think this field is still evolving. We are getting every new model, bigger models, small models. And if I go through my Twitter timeline, I keep seeing people experimenting with this. But then there are also one set of people who are actually trying to jailbreak these. So I really follow them. And so I think very basic things would be for any person to do today, as of today maybe, is very simple things like don't copy paste directly from there and just put it out, because firstly, hallucinations, we don't know is that what they are just spitting out is truth or not. Secondly, we don't even know if that is plagiarized. So you don't want to put yourself in a situation, let's say you copy an essay from there and next day you see some copyright claim to your work. Uh, so check the generated content properly. And what I've seen is there's a lot of plugins that are coming out, so for example, for ChatGPT, people are creating like, don't waste your time on this, plugins for everything, plugins for reading your emails, plugins for reading papers. So be cautious of those plugins, because there's a very nice example which is given by Simon Wilson actually. If you're not following, if not following him, please follow him on Twitter. He is actually doing a lot of work on jailbreaking systems and testing these LLMs. So he said that people are creating plugins for reading their emails and then also replying them automatically. And he said, think of a scenario where there's an automated plugin, an assistant which reads your email, forwards them to some other email, and then deletes all your emails. Think of such possibilities also. So just don't blindly go for automating everything. Like I see some of the posts on my LinkedIn feed also, you're using ChatGPT wrong, you're using this wrong, that wrong, do this, do this. And other than that, also, I think there's a very nice thing that people are doing some research on data poisoning of large language models. And it's come to light that because large language models are instruction tuned, uh, and so if you poison even very few samples of that training data, you might be able to sort of poison your model, and you can sort of make it give an output that you want. So data poisoning is something which is coming out, and which is a little alarming also, because it's the strength of these large language models lies on the data on which they're trained. But then this data is out, it's crowdsourced. And if there's an adversary which poisons this data, and then you blindly download this and use this for your application, then so you have to be aware that this is not Oracle. Be very careful when using them. And again, I think there's this whole talk about open source and, of course, proprietary. So at least for open source, you can download on your system. For proprietary, you'll have to send your data to them. I think there's an example of something where an employee actually put their documents, they wanted some help, so they copy pasted some of their documents on ChatGPT, and it went into the training data, and then it was actually giving out the details, so it had to be banned ultimately. So I think these are very common. I think these are not some very, I don't know, specific ones, but these are just common sense, I could say, guardrails.
Yes, absolutely. I think as you kind of highlighted, there are several challenges, right? One is like data poisoning, and this is something recently people have shown that it's fairly easy to poison these large language models, and the challenge is that if the models are poisoned because of the huge size of the models, it may be hard to detect them, even if they are available as open source models. Even if you have access to the models, it might still be very hard to detect those. The other dimensions you touched upon are dimensions like privacy, from the perspective of privacy of the person who is querying the model, right? Like the Samsung example. Or there may also be concerns from the perspective of say, copyright. Like the model might be trained on content that might contain copyrighted information, or information from perhaps the competing companies that as compared to your organization. So it's often important, as you point out in the book, to not just copy paste the response. It may be, while we are developing tools to detect all these kinds of issues, it may be good to at least rephrase in the case of generated text. So take the response from the LLM as inspiration, but rephrase, or kind of don't just use it as is, because it's possible that it may be just mimicking content which is copyrighted. So another dimension here is to ensure that these models are robust. It's often these models might be very brittle. So before building an LLM based application, it's important to stress test the models for robustness. This is one aspect that we have been working on recently. We recently open sourced a tool called Fiddler Auditor, which is a way to measure how sensitive the model is to minor perturbations in the input. If the input has not semantically changed, but syntactically it has been modified, we would expect the output of the model to ideally not change substantially. So that's kind of the intuition underlying the robustness checking that we're doing. Yeah, if you're interested in more pointers, I would encourage you to also take a look at a tutorial that we have been presenting at a few research conferences. We presented at the ACM Fairness, Accountability and Transparency Conference a few weeks back. We're going to be presenting the same tutorial at ICML and KDD conferences over the next few weeks. We'll be happy to share the link to the tutorial, and we would love to hear your thoughts and feedback. So another comment I hear, actually before going to the next question, so one related to the previous discussion on how to kind of balance creativity, innovation, and following the instructions in the regulations. One aspect I could think of is it might be helpful to perform experimentation in a sandboxed environment. So that way, if you think of, say, let's say you are at a large bank and you want to consider a new machine learning model for deciding whom to provide loans or credit to. So it might be good to simulate the effect of that in a sandboxed environment before actually deploying it on real people. So that way, it kind of balances performing innovation, performing some kind of creative ways of doing things, and testing the effect of those before actually deploying. So that might be a middle ground that might balance both these aspects, the following regulations and also supporting innovation or creativity.
Yeah, I think this is a great point, and I think this could also apply to the products. I mean, something pre-alpha or pre-beta stage, where you just open it up to a few people, and then in a more of a testing phase, and if the company has that bandwidth, and then I think this could, I think the way you talked about robustness, in a way, this could be stress testing robustness, and ultimately, then the product that comes out, at least. You'll be sort of sure that at least you've taken care of some of the main issues that could have come up, because ultimately opening it up to people and then testing on people is, again, I think, not a very good idea.
Yeah, of course, there is a tricky aspect with regulations, as I think one of the attendees points out, that often regulation raises the barrier for new players or for even investment, and as a result, it often helps the dominant incumbent players. So that's always a challenging aspect of regulations, and I don't think there is any easy answer. At least I'm not aware of a technical answer to this broader problem. So another question I see is, I didn't catch the discussion about model cards earlier. What are the best practices in creating model cards? What should be included, and how can I use them to align with other teams?
So model cards basically is sort of a document that gives all the information about your model. So it's an analogy that would be like you have labels at the back of the food items that you buy from the market. And so you have, what is the ingredients, when to use, when not to use, best before that. So we have very good templates. I think from Google, I think it was spearheaded by Margaret Mitchell, who sort of came up with the idea of model cards. And model cards can be as you can say, you can put as much of detail as you want, right from what are the libraries used, when you should use it, when you should not use it, what are the data that was used, which data you think is sensitive, who was involved in let's say, which was was the data crowdsourced, from where you acquired the data. So every little detail, and it actually depends upon you how much you want to, and then you can also sort of give where it could be used, where it should not be used. So I think there are great examples. If you go to the website of model cards, you'll find some great detailed examples. Now, if you even see on Hugging Face, all the models, they do come with model cards. So if you go click on them, but it of course depends upon the person who's filling them. So it essentially depends upon you, if you're the creator of the model or your company, how detailed you want it to be. And I also think that model cards are there. There are also data cards, which is specifically meant for data. I also think there could be something called model inventory if you are as a company, to have a clear idea of how many models you've deployed at this moment. So how many models are in production, how many models are not in production, how many models your customers are using, they fall into which field. So right if somebody was to ask, okay, how many models how many of your models are there in production at this moment. So okay, there are hundreds of them at this moment, and stuff like that. So it's essentially just more information as much as you can give, because that makes it easier for people, let's say, who have not been involved in creating the model, but they'll read the model cards, they'll get an understanding. And when you also try to describe things, some of the red flags or some of the problems with the models can also be caught at that very instant when you're defining something.
Yeah, yes, I think these are really nice points. And thanks to Dimple for sharing a link to an example model card from the project that they've done. And if you search for model cards on any search engine, you can find a set of links, including the link to the original paper titled Model Cards for Model Reporting, as well as, like as Parul mentioned, model cards provided by Hugging Face and several other players. So I know that you're based in India and you have been very much plugged into the AI and machine learning in Indian settings. Are there unique aspects and challenges or anything interesting you have come across when it comes to applications of LLMs and other generative AI models in Indian settings?
Like there's one at the back of my mind is, and I think it's something that we've been hearing everywhere now, that most of the large language models today are focused on English language. But what about countries and places whose native language is not English, like especially for India, who has so many different languages, we don't even have one. So how do we make these large language models or these services useful for others? So there's you could say, a group called AI for Bharat, which has been working. The people are from, some of them are from Microsoft, and they're working with IIT Madras, and they've actually come up with repositories where they have languages and data sets curated in Indian languages. And I think this is really a great thing that they're doing, because it's very difficult to find data sets in these specific languages. And they've open sourced it, they've put it on their website. So if people in India, they want to create a product which is localized, AI product, then we can use them ready-made, because I think getting data is the hardest hurdle that one faces. And essentially, I think going further, we should see more collaborations from countries whose native language is not English, to come out with such large language models which are like fine-tuned for their own specific languages. Because this is essentially when we say democratization of AI. So AI should not be limited to just few people, a few countries, or few geographies, but it should be, in a way, be accessible to everyone. And getting the data in your local languages, I think it's a great place to start with.
Yes. I think when I first got to know about the AI for Bharat initiative from our earlier discussion, I found it really, really fascinating. And they have developed an app called Jugalbandi, which provides a way for people, even people maybe in some remote village, to communicate through the app and get access to government services. It's a really, really interesting way in which they're leveraging generative AI and large language models. I would encourage all of us to check this out. And also, I'm kind of really excited and looking forward to an event, a virtual event that the ACM India KDD group is organizing on August 6th. So I will be part of a panel on generative AI in India, and one of the other panelists is a researcher who has been working on AI for Bharat. So if you're interested, please take a register for that event, and would love to have everyone join there. I think we have a few minutes left, and I'd like to take another question, which is, what are some things we can consider or implement to reduce the risk probability before deploying a model?
So I think if we want to ensure, and I'll just sort of digress a little bit and just give an example. We've all used mobile phones today, and I've visited a lab where these are actually created and made. And so every mobile phone undergoes a series of stress tests, about 100 or 1,000. So they are left from, let's say, some feet, and continuously they're switched on and off multiple times. And so they are stress tested so much. They put music, they're thrown from there to test whether they'll break or not. And so that before they land on our hand, it's ensured that they are robust, they've gone various tests, and they work as intended. So for AI, in the same way, AI models, AI products are also products. And so before releasing them, make sure they're continuously stress test, robust, check for robustness, check for have cybersecurity is an element which should be now become an integral part of our machine learning life cycle. Red teaming, bug bounties. So all these stuff, just make sure that you are going to ship a product, and this product is going to go in the hands of consumers, and the consumers should not be affected. I think if you go with that mentality, I'm sure you're going to create products which are safe. So ultimately, as data scientists, as machine learning engineers, our ultimate responsibility is to create products that are safe, and you have to ensure safety as creators of it.
Yes, absolutely. I think to kind of just to add to that, as technologists, we all have this shared responsibility of ensuring that various machine learning best practices, risk management frameworks, and so forth are followed. And the onus is on us as much as everyone else to kind of create awareness about these dimensions and work with other stakeholders, whether they may be from engineering, product, or legal, or security, and several other teams, including those who may be impacted by the machine learning models, to kind of collectively arrive at consensus and arrive at ways to address these issues beforehand. So thank you all for joining today's session. And as we mentioned earlier, like, we will share the recording afterwards. And if you are interested more, please take a look at the Parul's book. And Parul, I remember you may also have the link for kind of a trial access to the entire O'Reilly collection,
Yes.
right?
Yes, so I think for the first 10 days, also you can just log into the O'Reilly account, and then I also have the link for additional 30 days, so that makes it 40 days. So you have access to the entire O'Reilly platform where you can read books, including ours, but you can also read all the other O'Reilly books also. So we'll also share that link, but I think I had shared it already, but I'm happy to share it again in case it's not in the chat. So you do get access to it, but if somebody wants the DRM-free ebooks, please let me know, because O'Reilly can also email some books. So if somebody is really interested to read that, or I can talk to O'Reilly and they can send you DRM-free ebooks as well.
Sounds great. On that note, thank you all again for joining, and we look forward to seeing you all in the next AA Explained session in a few weeks. Thank you all.